Good afternoon and welcome to this fireside chat. What a fabulous, fabulous opportunity to welcome you to the Fred Hutch. I'd like to take a second to introduce a couple of visitors that we have that are with us today. First, I'd like to introduce Representative Harris and Representative Dolan. If you could please stand up and be introduced. Representative Harris and Dolan have been extraordinary supporters of the Fred Hutch and helped us put together our relationship with the University of Washington. Thank you so much for being here today. And if I've learned anything, you always introduce your boss. I'd like to introduce the chairman of our board, Kathy Surrey-Smith. Kathy, welcome and thank you for being here today. So this is truly a remarkable chance to get together and think about what kind of impact COVID and other infectious diseases have made in our world. And today we have with us Dr. Tony Fauci, who's the director of the NIAID. All of you know Dr. Fauci from the incredible role he's played in our national and global response to COVID. But in addition, his relationship with Larry is particularly remarkable because of how deep and how long it goes. Dr. Fauci and Dr. Corey were some of the pioneers who worked in HIV and forged that relationship in HIV and took it and made it such a big part of our global and national response to COVID. And thank you both, Larry and Tony, for everything you've done to bring our country to this point, our world to this point that we are today, because we'd be in a lot worse place without both of you. So thank you, thank you, thank you for being here. And now, before we introduce the Hutch Award, I'd like to ask for a comment from our interim dean and the CEO of the UW Health System, Dr. Tim Dellett, who's also an infectious disease doctor who went to Cornell. We will not hold that against either of you.
Great. Thank you very much, Tom. And as I was reflecting on the longstanding partnership between UW-Medicine, University of Washington, the Fred Hutch, it's not just in oncology, but it's in infectious diseases. It's in vaccine development, virology. And when I was thinking of Dr. Fauci joining us today, I was reflecting back to February of 2020, when through the Seattle flu study, which was a collaborative through the Brotman Beatty Institute, a partnership with the Fred Hutch, University of Washington, Seattle Children's, we identified at the time what was thought to be the first known transmission in the community of COVID-19. And as all of us know, we were directly impacted very early on by this pandemic. It's hard to believe that we're still talking about it 2.5 years. I don't think any of us would have envisioned that. But I also just want to thank you, Dr. Fauci, for all of your leadership, your courage throughout this pandemic, really focusing on what's right, trying to bring the conversation back to the public health emergency throughout this period of process. And we are so grateful for everything you've done for our country and really leading by example. So thank you.
Thank you, Tim. And before we start the fireside chat, one big announcement, which is tonight at the Mariners-Yankees game, okay? Dr. Fauci will be receiving the 2022 Honorary Hutch Award. Now, as many of you may know, the Hutch Award has been given primarily to baseball players who've made an impact on our society over the years, but there have been two special Hutch Awards, both of them extraordinarily appropriate. One was given to former President Jimmy Carter, and the second will be given to Dr. Fauci tonight. We could not be more proud to recognize his contributions and his impact on our society and world with the Hutch Award. Now, there'll be a lot of pressure on you to throw that first pitch out, okay? And if you think you're going to get off easy, I don't know, okay? So without any further ado, I'll turn it over to Dr. Corey. Thank you both for being here.
All right, I think I'm mic'd up. All right, we're going to do this in 3 parts. This is not hard for us. We've been doing this. A little bit of history of HIV. We won't bore you too long with that. Second is going to be a little bit more contemporary about HIV as the NASA of COVID and pandemic preparedness and vaccines. And the third part's going to be probably what most people want to hear, which is about Tony the Man, the Fauci effect, and really contemporary life as a scientist in the public eye. So we'll start off. All right. All right, 1981. Now, people don't know that he was really, not that much an early infectious disease guy. He was trained, but he really was a B-cell immunologist, really quite prominent, doing Wegener's granulomatosis.
Right.
Now, in 1981, he read that article in the MMWR about this disease of gay men. And frankly, he actually just shuttered his entire lab and started clinical work in sort of seeing AIDS. He and Cliff Lane and Henry Mazur, who were fellows with him, were really some of the first people to take care of patients with HIV. And, he started that trek, and that was really 2 or 3 years before I started into AIDS. And in 1984, at the age of 44, you were appointed the director of 43. Okay, giving him an extra year. We better not do that. He was the head of NIAID. And his first president that he served was Ronald Reagan. Now, this was a guy who wouldn't utter the word AIDS.
Right.
And he started diverting all these funds from that he was now director of to working on HIV. So I really wanted to ask him a question I've really never asked him before. Was there a backstory to this? Did you have a hard time with that? And what drove you to start doing that?
Right. Well, the way things work at the NIH, it is not up to, at least wasn't until then, for directors of institutes to lobby for money for their own cause, because as an institute director, you're in the executive branch, and theoretically and practically, you represent the president's budget. So O&B and the president makes the budget, and it comes in. And it was clear for the few years between when I started working with persons with HIV in 1981 and I became director in 1984, it was clear to me that there was very little enthusiasm for working on what I felt, as Larry said, I changed the direction of my career completely. As soon as I read the first MMWR in June of 1981, 5 gay men from LA with estranged pneumonia, pneumocystis, which I knew a lot about because I was an ID doc and I used to see pneumocystis on the NCI cancer wards of people on chemotherapy. So I thought that was kind of strange. 1 month later, in July of 1981, there was the next MMWR, which was 26, curiously, all gay men, not only from LA, but from New York and San Francisco. And as Larry pointed out, I don't know why or how I did that, because I had been pretty successful in the field of the interface between immunology, immunosuppression, and other infectious diseases. So I got very curious about this, and I realized that it was actually a new disease. It was kind of tough to convince somebody that you're actually reeling with it. They always say, well, somebody else saw this before. It's not brand new. So I got intensively involved in it. I completely turned around the direction of my lab, which was really quite successful, studying inflammatory diseases and the role of immunosuppression. Everybody thought I was crazy. My mentors, who, they weren't my mentors anymore, they were originally my mentors, said, you're really making a career mistake. You're on a trajectory academically, you're all in the right societies. Why are you studying this bizarre disease in gay men? But I did. I stopped everything I was doing and started admitting dozens of desperately ill men. It was very difficult to do research the way we do it because you were too busy taking care of really sick patients. But we got some interesting observations. At that point, it was clear that there were very few people in the field of HIV, because it wasn't HIV then. It was 1981, too. Remember, HIV was discovered in 1983 and 1984. So I figured we really got to be able to get people who are interested, immunologists, infectious disease people, into the field. That was the thing that allowed me to make a decision that I never would have made earlier. With all due respect, I didn't like administration at all, you know. Sorry. But I figured the only way that I could get really sharp interest in infectious diseases was to take the job as NIAID director. I didn't want it. They asked me to put my name in. I said, I don't want to have anything to do with it. I'm too busy taking care of patients. I'm too busy doing my research. But I got the idea that maybe if I did, I could do something that no other directors of NIH had ever done. Institutes. The NCI never did it. Heart, Lung, and Blood never did it. It was to actually, once you're in the position, to actually behind the scenes, actually lobby for money more than what the president's budget asked for, which is a big no-no. It's called busting the budget in Washington. You don't do that. You can get into trouble. So I figured, you know, what the heck? I'm only 43 years old. If I lose the job, I can do something else. So when I became the director, it was clear that Ronald Reagan, with many good qualities that he had, he did not recognize AIDS for what it really was and what it potentially could be. And as Larry said, to his historical, I wouldn't say shame, that's too strong a word, but to his historical diminution of his stature, he never mentioned the word AIDS until his second term, which meant he lost the bully pulpit of the presidency to get people galvanized to take this outbreak really very seriously. So it was at that point that I decided, and I asked the NIH director at the time, Jim Weingarten, I don't want to be circuitous and not honest with you, but I'm going to go ask for more money. Do you think that that would be okay? And he said, you know, it's maybe not such a bad idea, only don't say I said it was okay. So I did, and I started lobbying for some of the prominent congressmen and women at the time. Henry Waxman, so nobody knows who Henry Waxman was, very, very important congressman at the time. Nancy Pelosi, when she was first coming into the Congress. And I said, we really do need a hell of a lot more money than we have. And it was at that point that we got enough money into the field that young investigators saw it as an opportunity to maybe start a career in a new field. But that move to ask for more money than what the government was asking for was kind of a change in the paradigm. Now it's kind of like everybody does it, but back then it was something new. So that's the backstory of that.
All right. Well, that gives some explanation of how we started, which was in '85 and '86 when you started the AIDS Clinical Trials Group, which was really at that time was the treatment group, and we sort of wrote our first grant in that over the Christmas of '84. And I guess the revelation at that time, I guess, I'll leave it for you, is sort of obvious. You started a clinical trials group when there was really no drugs to test of worthwhile. And again, your thinking and boldness of that was?
Well, I'm looking around the room, everybody looks so young. Am I talking about things that long before your time? Once HIV was identified, it was only a matter of time that we were going to get drugs for HIV. The first one, as you know, was AZT, which was already developed as a not particularly good cancer drug. But the one thing about it that was important, its mechanism was it blocked reverse transcriptase, which was the reverse transcriptase inhibitors, of which we have a lot of really good ones now, nucleoside and non-nucleoside. So we felt that once we started getting a lot of drugs, we needed a very broad network of clinical trials. And this is where Larry and his group came in. That's when we first got to know each other back then. We knew each other before. That was when we first started developing a strong relationship. Is that we developed a clinical trials network before there were any drugs to test. And I got a lot of pushback from people in the academic community because as you all know, in the academic community, everybody needs funding, and when you see some funds going in one direction, you say, why isn't the fund coming in my direction? And people were saying, you're investing all this money in developing a clinical trials network, and you don't even have any drugs. In fact, we were criticized, and as it turned out, by the time we got the network going, we had a lot of drugs to test, and that was really the success story of how we developed ultimately from 1986, when AZT was tested and then given FDA approval in 1987, until 1996, when the first triple combination with protease inhibitors, and then all the fine-tuning of the drug development from 1996 to the present time was virtually all through what first became the ACTG. It was the ACTU, which is the AIDS Clinical Trial Units. Together as a group was the AIDS Clinical Trial Group. It was so successful, but you may get to this in your questioning, but then we saw the advantage of networks of clinicians throughout the country and the world. So we said, well, maybe we're going to need a vaccine network. And to Larry, actually, Larry started off before vaccines. He was doing the clinical trials of the drugs because of his work with herpes. Did they know about your work with herpes? Just kidding.
Probably not. Probably not. But that's okay. This is about you, not me.
So then we had more networks, and we had the HPTN, the Prevention Trials Network, which is really one of the most successful. That did all the things with pre-exposure prophylaxis and all that sort of thing. Anyway, that's how the network got started. We did it. It gets back to that Kevin Costner film, build it and they will come. So we built the network, and then we wound up having drugs to test in the network.
All right. I'm going to move us forward a little bit in time. We're not going to do old times too much. But next question on HIV is really about PEPFAR, which you did with President G.W. Bush. Now, for me, we took a walk at the IDSA meeting in San Diego, in which when you were starting to develop the program, frankly, you had just gone to Africa, I remember it was Secretary Thompson. And there was this concern about whether we should, do this. There was a concern, we had this guy, what was his name, Andrew Nastius from USAID, who said, Africans can't read, they can't take medicine on time. Frankly, Paul Farmer had already done work in Haiti to actually show that if you put someone in the family who, this was mainly with TB, to observe the person with therapy, that you could actually do this. But there's a lot of concern about the lifespan of the drugs. We're going to ruin it for us. But you went ahead with that. And I think it's really important for people to hear the PEPFAR story. I mean, it's really one of the most successful programs in saving lives in the entire, maybe ever, save more lives, I think, than any other program ever in the history of mankind. So, how did it get created? And also about your thoughts and visions of where it's going now, and what do you think it should be?
Well, for those of you who are not familiar with it, many people are, the PEPFAR program is the President's Emergency Plan for AIDS Relief. I gave it that name. And it is an example of the right conflation of things at the same time. And the story, very briefly, but I think it's a really important story because it transcends HIV. And it was that when I was those first year in 1981, 2, 3, 4, when Cliff Lane, who some of you may know, was my fellow in Henry, Missouri, who is another very good infectious disease doc, we were like kind of the triumvirate of people who were taking care of all of these desperately ill young men with no therapy except treating their opportunistic infections. And that was really impressed me then about how frustrating it was when you're in a room with a patient and you have nothing to give them except, Band-Aids on hemorrhages. But the core illness that they had, we didn't have any drugs. So that was embedded in my memory. When the drugs became available, particularly the highly effective drugs in 1996 and 1997, from 1997 to the year 2000, we completely transformed HIV. People who had 8-month lifespan were now having projected to be normal lifespan. I think any of you who've been involved in HIV know it was one of the most successful transforming events in medicine to have people who had a 98% mortality now had like a 99% recovery and normal lives if they took their drugs. So I went from the dark years of my life to seeing people who now, with 1 pill a day, were leading normal lives. Then, when it became clear that there were a lot of people, mostly faith-based people, who were saying, you know, maybe we need to get more of these drugs distributed with some equity throughout the world, because only the rich countries, because they were very, very expensive drugs. Still working? Yeah. It was very expensive drugs. So I had been going to Africa multiple times, and I had a scene I remember in the Mama Yemo Hospital in Uganda, where I was making rounds. And we were making rounds on patients in 2000, I think, the year. And it was a flashback for 20 years when I was seeing patients, but I had no drugs to give them because there were no drugs. Now, in the year 2000, they were in the same boat as I was, because they were seeing patients, they had no drugs, but there were drugs, they just didn't have the drugs. So that became very, very clear to me that we needed to do something about that. So at the same time, people were asking President George W. Bush, is there anything that we could do for people in sub-Saharan Africa? I had known President George W. Bush because following 9/11, there was the anthrax attacks, and I was put in charge of developing medical countermeasures against bioterrorism, including, interestingly related to monkeypox in a second, the smallpox vaccine that we made 100 million doses of to be able to be ready for a smallpox attack. So I developed a very good relationship with President George W. Bush. I had known his father very, very well, George H.W. Bush. And George W. Bush and I developed a good relationship. And after the first year, 2001, in 2002, at the time that this drug nevirapine was being used to prevent mother-to-child transmission, he called me in his office and said, I want to send you and Tommy Thompson, who was the Secretary of HHS, to Africa to see if we could do something for the Africans. I mean, something that might help them. So we had an easy win with giving a single dose of nevirapine to the mother during labor and a single dose to the baby to essentially prevent by 75% transmission. So I went to Africa with the Secretary, and I went around and I looked around at the possibility, and I came back in April of 2002, and I walked into the Oval Office, and he said, let's go into the Roosevelt Room and present it to the cabinet. And I made a case for a $500 million program for mother-to-child transmission. That was all it was, just a well-defined program. When I presented it to President Bush, he got so excited by it that you could actually save so many children from being infected. And I thought it was over. I thought I was done, go back. And he grabbed me and his deputy chief of staff, a guy named Josh Bolton, and said, this is not enough. Go back and give me something that's totally transforming, not just for mother-to-child transmission. And I was sort of shocked. He had given me $500 million for this program. And I said, Mr. President, this is going to cost billions and billions of dollars. And to his phenomenal credit, he said, let me worry about the money, go put the program together. So for about, I'd say 7 or 8 months, from May, June, July, August until December, I went back and forth with the White House, you know, how many countries? 12 countries, 11 countries? Should we include Russia? Should we include China? Should we include India? Back and forth until we finally got it, which was 14 countries, 12 in sub-Saharan Africa, 2 in the Caribbean. And I put together a program asking for, you know, $15 billion. I went like that when I asked them for it. $15 billion over 5 years to treat 2 million people, save 7 million infections, and care for 10 million people. And I wasn't sure they were going to accept it. He was going to accept it. And then finally, right before the State of the Union address, his team called me down to the White House to help him, his speechwriter, Mike Gerson, who some of you may know, he's a very well-known columnist, to write the speech in the State of the Union address where he announced it. And he announced it without telling anybody. He didn't ask for anybody. It was typical George Bush. Didn't want anybody to know, didn't let anybody know in the press, didn't let the Congress know, just go ahead and did it. And that program now, 20 some odd years later, is saved about 18 to 20 million lives and have given a total of about $82 billion. So it is, to me, I mean, the credit all, and I say this with all sincerity, goes to George W. Bush. It would not have happened if he didn't send me to Africa. I mean, he was totally committed to doing this. And there's a side of him that most people don't appreciate, of a feeling of, as he's told me his exact words, that those of us who are privileged to have so much have an obligation to give to people who don't, which was really phenomenal.
Okay. All right. We're now going to shift to a little bit about pandemic preparedness and vaccines. I'm going to do a little talking for a minute just to give some history so that he can fill that in. So I'm going to say one of the great legacies in your career is that you've built an incredible research infrastructure for infectious disease vaccines. It's been through the Vaccine Research Center, in the academic community, through program projects in HIV vaccinology and pandemic preparedness, public-private partnerships. It's truly a lasting legacy. Now, there's a Seattle-based vaccine study. It's early in the mid-90s. We've both been started to dabble in HIV vaccines, but you had started already the AIDS vaccine evaluation program. But we were working on primary HIV together. Tim Shacker, my fellow, with Michelle Berry, and that you had Jeppy and Tewak in your lab. And we started in sort of the mid-90s, in which we treated patients with very early HIV infection. We called it primary HIV. And we treated a number of people within a week of them acquiring HIV. We hit them with triple drugs, and they immediately responded, and we biopsied their lymph nodes. Tim was really great at taking body parts out of people. And we would biopsy their lymph nodes at the very first visit, and then after sort of therapy. And Jeppy and Tewak found highly integrated latent virus in their lymph nodes in both the initial and the follow-up biopsy. Really, therapy didn't touch it. In science, you hope occasionally there's an aha moment. This was a oh shit moment. It was, and then I remember the Saturday morning calls, because that's when we went over data, and you saying there's no way to treat ourselves out of this epidemic. We need a vaccine, and it needs to prevent acquisition and latency. And frankly, that was career-changing for me. I actually left HIV therapy and moved to vaccines. And you followed the data, and this is where I think you've been an amazing leader, and you created an amazing vaccine infrastructure. I mean, you started in 1999. Between 1999 and 2000, you created the HVTN, you founded the Dale and Betty Bumpers Vaccine Research Center on the NIH campus. You established the large collaborative academic consortiums on HIV immunology. And we wrote this policy piece on the global HIV enterprise, in which we asked all the countries funding HIV vaccine research to A, start it, and B, complement each other. Mm-hmm. These programs were large in dollar amounts. They were huge in scope. Now they're in their third year, 7-year cycle. So what we have here is really big science. And the question here I want you to comment on is, few other institutes have established such big science structures to solve a problem. And can you talk more about your thoughts on large science models for disease research? Would you do it again? And if so, why?
Well, I mean, I think you sort of hinted at it. It became clear that the only way, based on the big program that we were doing with therapy, which, as Larry said, as successful as that was, the phase that we were focusing on is we were looking 20, 30 years ahead. We did the math and said, if you give people therapy that's lifelong in its requirement, and you have 1.6 million new people getting infected every year, at the end of a certain period of time, it's going to be unsustainable. You're not going to be able to get all people treated from an economic as well as, any other standpoint. So it became crystal clear that we absolutely needed a vaccine. So the aha moment, that was the, whatever Larry said, was that when you get infected, unlike almost any other infectious disease, we showed in the beginning that literally within minutes to hours to days, you develop an HIV reservoir. And once you have a reservoir, you're done. That means you're going to have to treat that person forever, because it isn't like polio, which you get infected, the virus starts replicating multiple rounds in your gut, and either you clear it or it invades neural tissue when you get paralytic polio. But you have a number of days for the immune system to clear polio. The same way with smallpox, the same way with other. HIV was completely different. Once you got infected, that was it, which made Larry and I come to the conclusion on those Saturday morning discussions that it was absolutely essential that we develop a vaccine. Now, the only trouble with developing a vaccine, and why we're sitting here today and we still don't have a vaccine, is because this virus, as many of you know, has the capability that as soon as you get infected, it integrates itself into your genome, and then you have latency, a reservoir, and then you're in trouble. So we've got to do a vaccine that is better than natural infection. When we were trained, our mentors used to say the best way to get a vaccine was to mimic natural infection without hurting the patient, which is the reason why you get live attenuated vaccines, whole kill vaccines. Most recently, you get recombinant proteins that reflect the business end of a pathogen. But we had to do better than that. And that led to a long, long road of lack of success. In fact, some vaccine trials even wound up having the opposite deleterious effect of making vaccine inducing more susceptibility to getting infected because you activated the immune system. But then, I don't know whether you're going to get into that, but Larry had the idea that maybe if we used monoclonal antibodies that were able to protect, we could be able to determine what it is you need to induce to get a good vaccine. So we used the passive transfer of monoclonal antibodies to show that you could protect at least against the strain that's sensitive to the monoclonal antibody, which is, people look at that experiment as an unsuccessful experiment. It was a phenomenally successful concept developing experiment to show that a monoclonal antibody, although it doesn't protect against all infections, it protects against the strain to which the monoclonal antibody is developed against. And that's what we're doing now with the combination of prevention by passive transfer to developing what the right approach to a real vaccine-induced prevention is. It's a really complicated, interesting story. It depends on, if you look at it as a success or a failure, it's very successful at the same time as we don't have a vaccine yet.
Okay. All right, we're going to switch now. COVID-19. We're at the epicenter of the initial outbreak. WA1, Washington 1, is considered the ancestral model strain. This center.
I developed the ancestral model strain. I created it.
That's right. You let it loose.
I was in my kitchen.
You let it loose. Yeah.
Right.
Okay. Gain of function. Here we come. You're making aranja, Italian meatballs, and that's a gain of function. All right. So Tom here, Trevor Bedford, Helen Chu from the UW, Keith Jerome, Alex Greninger. They all played major roles in Seattle's response. So let's look back, and I'm going to ask you, maybe a difficult question. As a country, what did it initially do right, and what did we do less right in the first few months of the epidemic? And if you would, what would you want to see a change for the next time when the next epidemic happens?
Well, I get asked that question a lot, and in many respects, it depends on how you ask the question. And it is that if we knew in the first weeks that you had WA1 here, what we knew now, we would have done everything different. But the country would not have been acceptant of what we were saying. Because if you think about it, when we were looking at one case in Washington and a couple of other cases there, what we know now is that as we were looking at 1 and 2 cases, there were hundreds of cases that were spreading throughout the country that turned into thousands, that turned into millions. And what we didn't know then, but we know now, is A, unlike what we originally thought, it isn't just animal to human, it's human to human. B, it isn't just human to human, it's highly efficient human to human. C, that it's transmitted mostly by people with no symptoms, and the entire CDC program was what's called a syndromic program, which means you only test people who have symptoms, which retrospectively was huge when you were having 50 to 60% of the transmissions were occurring from people who did not know that they were infected because they were without symptoms. And you were looking for the keys under the lamppost of the people who were infected. I mean, at that point, if we had turned the clock back, we'd say, okay, it's January 30th. I know you're gonna have tough with this, but everybody's gotta wear a mask, and everybody's got to stay 6 feet from each other. But Dr. Fauci, there are only 3 cases in the country. Trust me, it never would have happened. Never would have happened. So you're right. If we knew then what we knew now, and the rest of the country knew then what we know now, we would have done a lot of things differently. A lot of things differently.
Okay. So let's talk about now. How are you feeling about the now? It's clear we've saved an enormous number of lives. We've created the tools, vaccines, right. We have Paxlovid. But we're still in a pattern. I just looked it up. I mean, we're averaging 400 deaths a day, so we're on a track of having 150,000 excess deaths with our current status with Omicron strain. So your thoughts about what should be done? Can we do better? Should we do better? What can science do as we move this forward?
Well, it isn't necessarily what science can do. Is what the unfortunate thing that I've said many, many, many times. It irks people when I say it, but it's the truth. That if ever there was a disease as formidable as this disease, which has done unprecedented things in infectious disease, what other infectious than that has a situation where every 3 to 4 months you get a new variant for 2 and 3/4 years? What disease do you know that you can get infected, recover, and get reinfected, where you can get vaccinated with a good vaccine, get infected, and still recover and get reinfected? I mean, it's sort of like this virus is playing a very, very cruel and nasty trick on us all. So, I mean, we're living in an unprecedented situation. Superimposed upon that, the thing that I think is really one of the most unfortunate things I've seen, that if ever there was a situation where you needed the country to pull together against a common enemy, which is the virus, we have a nation that's extraordinarily divided, where the unthinkable is, where a decision as to whether or not you're going to wear a mask, is dependent upon whether you're in a red state or a blue state. I mean, it's the truth. If you look at the data about the level of vaccination, if there's one thing that's clear, is the Kaplan-Meier curves that look at hospitalizations and deaths of unvaccinated people, vaccinated people, vaccinated and boosted people. It is incontrovertible, the difference. And yet, you have people who don't want to get vaccinated for any of a variety of reasons, ranging from pure anti-vax to just because that, we're telling them to get vaccinated. We're in a very difficult situation. So what do I see? We have 67% of our population is vaccinated. Of those, 1/2 are boosted. So 1/2 of 63, that means 1/3 of the people in the country are vaccinated and properly boosted. I mean, how could that possibly be when you have a disease that's killed 1 million Americans and you have a hesitancy to use a life-saving intervention, which is a vaccine and a booster? It seems like what world are we living in? When you tell people they need to mask in an indoor congregate setting when you're in a zone that has a high dynamic of infection, and that is looked upon by a lot of people, not everybody, as an encroachment on your freedom. We've never had that before. It's almost inexplicable.
Right. And it's a very effective, look at the research community. We've created these incredible tools, and yet they're not being implemented. And it's how do you overcome that frustration? How your thoughts on, let's say, the research community, can we do anything to change this?
Right.
With respect to implementation, behavioral implementations. I think some of this does actually apply to cancer also, with respect to both the disparities and the issues of what we do in research. One thing that has transcended both HIV and COVID has been affecting communities of color and healthcare disparities, and that whole issue of how do we overcome disparities? How do we overcome biases in clinical care? How do we overcome biases in our research infrastructures? Thoughts about that, and as to potential solutions and what research institutions should do in this arena?
Well, we've seen it clearly in HIV. You have 13% of the population is African American, 44% of the new infections are among African Americans. Of that, 65% are among men who have sex with men, and most of them are young, between 18 and 39 years old. So right away, you have a phenomenal disparity, and that relates to things that are not racial at all. It has to do to social determinants of health. It has to do to accessibility. It has to do to stigma. It has to do with all that. It came home to roost really with COVID, where you have a disease that, if you look at the distribution of infection, the infections are disproportionately among brown and black people for reasons that relate to the broader issue of economics. Most of them have jobs that require them being out into the community and not sitting behind a Zoom thing doing their work the way you and I do it. So they're in the community, susceptible to getting infection. But the real proof of the social determinants of health are that when they do get infected, they have a substantially higher risk of hospitalization and death due to the underlying conditions that they have that are not racially determined, that have to do with the social determinants of health. Poor accessibility of health care, not getting things diagnosed early, poor dietary accessibility of good diets that leading to things like obesity and diabetes. So if you look at the 5 or 6 things that make somebody more susceptible to hospitalizations and death, it's obesity, it's hypertension, it's diabetes, it's chronic obstructive lung disease, it's cardiovascular disease, kidney disease, all the things that when you compare the general population or a white population with an African American population, and in every single one of those diseases, that incidence and prevalence of those diseases is higher. So you say, what are you going to do about it? The trouble is, since the social determinants of health, when I say this, a lot of congressmen get really pissed off at me, but the social determinants of health, when you look at the brown and black population, are rooted in institutional racism going back to slavery. I mean, that's it. I mean, this is the country, our country has our original sin of slavery, and it just goes through the opportunities that people have. So the social determinants of health start when an African American, or in many respects a Latina, is born. So in order to correct it, Larry, that's a multi-decade commitment. Right. So when you say, well, we're going to learn the lesson of HIV and we're going to learn the lesson of COVID, and then COVID goes away and this other goes away and everybody's corporate memory disappears. So I don't really want to be too pessimistic about it, but I am not so sure that we are going to be very successful in righting those wrongs of the social determinants of health.
Okay. Well, I was going to actually tell the story. Should we tell the story of Saturday mornings with Moderna and your role in that? Are we allowed to? No. Okay. We're going to pass on that one. Okay. We're passing. All right. All right. An easy one. Now, we're going to section 3. We're going to push him a little bit about him as the leader and the person. So, the Fauci effect, the interest in medical and biological fields and research. Your own personal comment on this?
Well, the so-called Fauci effect is what a lot of people want to go into public health and medicine particularly, and science, because of the visibility of public health and science when you have a historic outbreak. And since I happen to be a very visible person, it's called the Fauci effect, which is sort of like, trust me, I don't get excited about that. I mean, it's nice, but I mean, people go to medical school now, people are interested in science, not because of me, because most people don't know me, who I am. My friends know me, my wife knows me, but people don't know me. It's what I symbolize. And what I symbolize in an era of the normalization of untruths and lies and all the things you're seeing going on in society from January 6th to everything else that goes on, people are craving for consistency, for integrity, for truth, and for people caring about people. So because I happen to be a visible person, it could have been somebody else. It didn't have to be Fauci. It could have been Smith or Jones or somebody else. But they call it the Fauci effect because I'm very visible. But the other side of the coin of that we should mention, which is really painful and a shame, is the abuse that public health officials get for saying the truth about what's going on. I mean, I've never seen in history that physicians, public health officials are getting harassed and threatened. Not just me, I get that all the time. That's why I have these guys with things in their ears that are taking care of me. But that's really horrible for public health, where when you have physicians and public health officials get harassed, their family gets harassed because they're telling people to do things like get vaccinated or wear a mask. But that's the other side of the coin
Right.
of the Fauci effect is the people who would like to see Fauci killed.
Right. So I had a couple of questions. You've sort of answered a bit about that, but I'm going to ask, in your opinion, you know, is academia and its leaders doing their job in this arena of sort of protecting the scientific community discourse? You know, how does one deal with congressional leaders who promulgate unscientific ideas, yet control funding for public
Right.
institutions? And are institutional leaders handling this well? You know, are we handling this issue of the, you know, your favorite fellow, Rand Paul, and a lot of other people who are, you know, just promulgating distruths, but yet they actually do control public
Right.
funding, and how we as a scientific community sort of try and go after this?
Vote. You know, vote.
Okay.
No, I mean, that's really, really very important. I've given a bunch of commencement addresses this past May, and depending upon what university or college or medical school, I would give something specific for that. But the one core in every one of the commencement addresses was to plead with the young people to don't accept the normalization of untruths. And because there's so much preposterous lying that goes on, including, and unfortunately it's true, and I'll get 4,000 emails about this tomorrow, that members in our own Congress and our own Senate who just get up and say things that are total lies, you know, I mean, every single day, you know, vaccines kill people, you know, that kind of thing. It's so much untruths that people who have a lot of other things in their lives that they have to worry about, they kind of start accepting it, and all of a sudden, lying becomes normal. And if the one thing you want to shake the young people in the country to say is, don't accept as normal flagrant distortions of truth and reality. Because once you do that, nothing counts. Truth doesn't mean anything. You know, it just, anybody can say anything they want, and then that's it. So that's an indirect answer to your question, Larry, is that we've got to keep pushing back against the distortions of reality that we see. And we can't give up and say it's a waste of time, because if we give up, then this will become part of our society, and then we're really in trouble.
Okay, well said.
Sorry to get so serious here with you, but it's the truth.
Yeah. All right, maybe we'll get a little bit more optimistic on this next one. There's lots of young people being trained in science. They see these discourses. I think there's some sense of, what do you think about the future of US government-supported, taxpayer-supported research? Are you optimistic about it? Should researchers and future scientists feel insecure about research funding in the United States?
Well, right now, including with all the stuff that's going on that I just mentioned, which is unfortunate, we have been fortunate that there has been bipartisan support of research consistently for as long as I've been there, with very, very few exceptions. That's one of the things that, even with a great deal of divisiveness politically in our society and in the Congress, that people can agree upon the importance of supporting biomedical research, which is the reason why the NIH budget and other science organizations' budget have continued to increase and grow. So I don't see that necessarily changing. I mean, obviously, we're in more of a political battle in Washington about the reconciliation bill of the horse trading that goes on. I'll put this in this bill if you put that in that bill, that kind of thing. But in general, the Congress is really quite supportive of biomedical research.
It's sort of an interesting issue that the guys who lie still are sort of voting occasionally for funding.
Yeah.
Which is sort of like they're just sort of saying, I'm recognizing I'm lying, but I'm going to do this anyway.
Yeah, yeah.
And that is, I guess I'll make it as my political observation of what the hell is going on. All right, I'm going to ask monkeypox questions, and then we'll open it up, because I think some of it are so obvious. We're dealing with almost, okay, we have a 98% outbreak in the gay male community. It's like, okay, stigmatization versus public health, sort of reliving, the early outbreaks of HIV. Is this playing out differently? How do you see it playing out? What are your thoughts about it? Obviously there have been some decisions made about preparedness and the vaccine, et cetera,
Well, there are some similarities and some really striking differences.
Okay.
I mean, if you look at HIV, HIV is not a virus of gay men. It's a virus that will infect anyone that engages in a certain type of behavior. And it just so happened that that virus got inserted into the gay community at a time when the gay community was going through this sexual revolution of being able to be free of the constraints of the stigma and the persecution that they were going through. That the whole story going back to the Stonewall Inn riots and the idea that the expression of sexual freedom, which is fine, just happened to be unfortunate that a bad virus was dumped into that. But we know that HIV in the developing world is, 50-50 heterosexual or injection drug use or things like that. I think we're seeing the same thing with monkeypox. The same thing. It was just very unfortunate that a virus that was not a problem when everybody was vaccinated with smallpox, that when we stopped vaccinating with people with smallpox vaccine, then all of a sudden this virus that was indolent in certain animals that occasionally would jump into a human, that would be a dead end because almost everybody was immune to smallpox. And then in 1977, 1980, when we stopped vaccinating people throughout the world for smallpox, then the rest of the world became susceptible to smallpox, which doesn't exist anymore, but to monkeypox, which does exist. So then it's sort of a diabolical situation where those who would have been protected 40 years ago are not protected now because immunity wanes and most of those people are so old that they're not around anymore. And then you had an event, and epidemiologically they're tracking it now, that somebody was in Africa, got infected by the standard, endemic animal to human jump, happened to be a gay man, went into one of those gay pride galas that took place on the Canary Islands or someplace like that. I don't know exactly. There's a lot of different epidemiological strings to that. And then all of a sudden it got inserted into that population. And there's nothing special about the population except of the sexual networking in a gay population that is an easy entree to a virus. That's the similarities. The difference is that in 1981, when we were talking about my first experience, we didn't know what the etiologic agent was. We didn't have a diagnostic. We didn't have a therapeutic, and we still don't have a vaccine. Fast forward, today, we know exactly what the agent is. We have diagnostics, we have therapeutics, and we have vaccines. So it becomes an implementation issue. How can we, with equity, without stigma, get these interventions to the people who need them at the same time as we don't stigmatize them? So that's the real challenge that we're facing now. So there's some similarities and then some real differences between the two.
All right. Well, I think it's time to get some people to ask questions of Tony other than me. So how about having a brave couple start?
Thanks, Dr. Fauci. Really appreciate you being here.
Could you state your name?
My name is David Glass. I'm a postdoc here. So you famously held up Alex Setti and Shane Crotty's paper at a congressional hearing saying this is the kind of immunology research we need to fund. So at the onset of the next pandemic, what do you think are the immunological investigations that are most important to do as quickly as possible?
When you say the next pandemic, are you talking about monkeypox or any next?
TBD.
The TBD, to be
To be
determined.
determined.
Well, you get to wax eloquently no matter what, okay? He gave you a great opportunity there.
Okay, so, I mean, one of the things, I mean, the reason I put up Shane's paper because it was a good paper, but I think one of the things that we've got to do is that we've got to be much more comprehensive in our immunological analysis of pandemics, and I think one of the really great examples of that and why we need to do more is what we're seeing with COVID. You know, COVID, if you look at vaccines that induce not just antibody response, but obviously T cell and B cell memory responses, that what looks like it's holding strong is protection against severe disease leading to hospitalization and death. What really goes away very, very rapidly, obviously, is protection against infection. And the reason is that we systemically vaccinate. You get high levels of antibody that protect, as well as T cell responses that protect organs like the lung. But the only way you protect the upper airway is if you get enough antibody that spills over because you're not in situ making good antibody in the nasopharynx because you haven't vaccinated via the nasopharynx, which is the crying argument for mucosal immunity studies. So if ever we're going to look about pandemics, which can occur anyway, but the ones that we know of, pandemic flu, COVID, it's all mucosally entered. So I think we really need to get the immunologist in the crew getting excited about taking a look at mucosal immunity a lot more seriously than we do.
I'd say epitope-specific responses, that we have not defined them
Right.
as well as we can or should, and really innate immune responses, certainly for RNA viruses. There are things here with SARS-CoV-2 that is...
It's begging for an answer.
It's invading innate immune responses, and at the moment that we use that term, and we're clueless as to really what some of the genes are. So I think both of those are areas I'd sort of say greater emphasis is needed. Okay.
Hi, Dr. Fauci. Thank you for being here today. My name is Pritika Banerjee, and I have sort of a generic question. Given your years of experience with HIV, now COVID, and now monkeypox, with viruses and dealing with viruses specifically, what do you think are some of the common learnings or best practices that can be applied in their disease control, or common threads that link controlling these diseases, like the best things that we should keep in mind when dealing with new viruses?
Yeah, that's a really good question. I think the best thing to keep in mind when you're dealing with a new virus is don't ever underestimate an emerging infection, because we have examples of, I mean, I gave a few examples before of when we first recognized SARS-CoV-2. Since it was a coronavirus, we hearkened back to SARS-CoV-1. We said, hey, you know, inefficiently spread from human to human, it goes from an animal to a human. Symptomatic people are the ones who spread it. You get very little spread through asymptomatic. Aerosol, not spread at all through aerosol. Complete underestimating what an emerging infection can do. When we first saw HIV in 1981, the only thing we saw were desperately ill gay men, which was the tip of the iceberg, because as soon as we had a test for HIV, we found out that there were millions of people more infected with HIV who were actually sick with HIV, hence the tip of the iceberg. So the lesson that I take away is don't ever underestimate ever an emerging infection. You never know where it's going. And that's where we are with monkeypox right now, as a matter of fact.
Dr. Fauci, people are concerned about what's going to happen in the fall. And I'm just curious, in your view, what can people expect when it comes to any new potential variants, the severity of that variant, and the importance of boosters?
Well, let me answer the last question first. Boosters are going to be extremely important because we know very clearly that immunity, at least against symptomatic infection, maybe not so much against severe disease, wanes at about 4 months or 5 months. So right now, we're concerned about there being a surge in the fall. We don't know exactly when it's going to occur because the thing that surprised us is that everybody who saw BA.4/5 come, we thought it was going to go down by the end of July and essentially be none, but now we're having still 400 deaths per day and 150,000 infections. So if we get BA.5 that goes into September, then you wouldn't be thinking about a fall surge. You're still in the summer surge before you think about a fall surge. But the short answer to your question is that we will very likely be using a BA.4/5 bivalent booster starting in the fall. Very likely. Pfizer will have it by first to second week in September, and Moderna will likely have it by the end of September, the beginning of October. So you're gonna be probably hearing soon about a big push to get people who have not been recently boosted to get a booster shot as we enter into September and October.
Thank you, Dr. Fauci, for all of the explanation, the history. It's very educational. I learned a lot. Thank you. And then I'm so also very thank you for Fred Hutch to have the opportunity for me to meet you. It's a great honor. I'm having a question. It's about the vaccine design that we are using currently. We target only one protein, but actually in the immune response is always against multiple antigen. And then how would you how would you explain that the future of vaccine should actually change instead of just targeting one protein into multiple antigens?
No, that's a very good point. We have the same issue with influenza where we focused so much on the hemagglutinin when in fact probably neuraminidase is equally as important. Yeah, I mean the receptor binding domain of the spike was felt to be the most important because of the importance of the binding to the ACE2 receptor. But you're absolutely correct. Because we rushed into getting vaccines out there right away, other elements of the virus were, I wouldn't say we're not paid attention to, but we got the mRNAs and the ad vectors out pretty quickly. But right now, the second and third generation are looking at the entire element of the virus, not just the spike protein or particularly not just the receptor binding domain. In fact, some of the mosaic proteins that are being used now on nanoparticles have other elements of the virus besides just the spike protein.
Hi, Dr. Fauci. I'm Marian Newhouser. I'm a professor in our cancer prevention program here. And like you, how you don't understand the vaccine hesitancy and the science hesitancy. I think most of us in this room also don't understand that. We spend our lives in science. Most of us have been, science nerds our entire life. What are 2 or 3 things that you might have learned from talking to millions of people across the country that have worked to help dismantle some of the myths and some of the misperceptions that people have about science and about vaccines that we can use when we talk to people?
Well, the one thing that I've learned from trying to understand vaccine hesitancy, which is just a very specific component of anti-science, is that there really is a heterogeneous group of people. And if you make them unidimensional, you're going to miss the fact, because some people don't want to get vaccinated because they don't have enough information about it. And it's not that they're really inherently anti-vax. And others, because so much misinformation is thrown at them that they don't have good trusted messengers to give them the right information. And then others that are just hardcore, that there's nothing that you're going to do to change their minds. So what we try to do is to, the same way misinformation tends to flood the system, we try to flood the system with correct information that's delivered in a non-pejorative way by trusted messengers. You know, I go out and encourage people to get vaccinated, and it's probably much more effective when a trusted messenger goes out there, and that's the reason why I've done a lot of those public service announcements with rap groups. Like, who knew when I was in medical school that I'd be there with rappers? But it works. They listen.
Steph Curry. Hey, listen. All right.
Thank you, Dr. Fauci, for sharing your experience with us and being here. My name is Daniel Lane, and I was wondering, from the perspective of the next pandemic that's coming, you were speaking of the president's bully pulpit and the need to try to get ahead of it, especially with a reticent public and the divided nation as it is. I was wondering, from the health institution perspective, and especially when trying to share it with the president and leaders of the country, what elements of the virus and specific properties you think are most necessary when gauging the next pandemic for helping to figure out how much the president should try to push ahead on health initiatives before waiting for people to realize as a broad population exactly how important it is to step out and perform preventative measures like masking.
That's a really good point. I think the president, and we're very fortunate because President Biden has been very, very much upfront out there and getting criticized by the far right for that, to really get out and use the bully pulpit of the presidency, which is right from the very beginning. When he asked me to be his chief medical advisor, he said, I want to be out there. You just tell me and tell us what we need to do out there, because he wanted to use the bully pulpit in a very positive way as opposed to in a way that confused the public, which we had seen previously. It really gets back to what I said in one of the early questions that Larry asked me, is that I felt badly that President Reagan did not use his extraordinary popularity, because, you know, again, many people in this room weren't paying attention to it back then. That was a long, long time ago. But he was a very, very, very popular president. And if he had just gotten up and said a few things that would have really turned the tide of the awareness of HIV, it could have made a difference. So I always encouraged, I mean, I started to make some progress, pretty good progress, with George H.W. Bush, who, when he was vice president, to his great credit, we haven't spoken about him, George W. Bush's father, when he was running decided he was going to run for president at the time that he was vice president, he came to the NIH to visit me to learn about this unusual disease that he knew his administration was not paying much attention to. And, you know, there's an iconic picture, if you look in the history of he visiting the NIH with Barbara Bush, his wife, holding a little child who was infected. That was that visit that I brought him to the NIH. And Phil Pizzo was at the NCI at the time, and Phil was taking care of children with HIV. And the idea that the wife of the president could actually take a baby and hold the baby in his hand was worth 100 PSAs on getting people to appreciate what HIV was. So it's really very important.
Oh, hi. I'm Kathy. I'm an apheresis nurse, and I'm just curious, with all your sort of history and experience with all this kind of infectious disease and pandemics and everything, what keeps you up at night as far as what's next? As far as, is it the next iteration of COVID? Is it glaciers with the new pathogens that are coming out? You know, what is it? And what can we as members of the community do to help prepare for that?
Who should answer that, you or Chris?
I don't sleep anyway, so it doesn't really, it doesn't matter. But, you know, I'm going to backtrack on your question. But the thing that people would always ask me, what's your worst nightmare? And if you go back and look at things I've written 30 years ago, 20 years ago, it was, and I used to say it repetitively, it was the emergence of a new virus that's respiratory borne, that has a high degree of transmissibility, and that is capable of a high level of morbidity and mortality. And unfortunately, my worst nightmare I'm living through right now. So it isn't like I'm not even worried about my next nightmare. I'm living through my worst nightmare right now. And it just, it's the terrible gift that keeps giving. We're going into our 3rd year in January. No one in their wildest dreams would have ever thought that we were going to have a virus that is as uncanny as this, that has already killed 1 million Americans. So I don't mean to be facetious, but I'm still in this nightmare. I'll wait for the next one.
All right, last question.
Hi, I'm Denise Galloway. First of all, I feel your pain about people not taking good vaccines, since I've been working on HPV for a long time, and there's another great vaccine that people won't take. But my question has to do with I've been reading about a bill that's before Congress to prevent the government from funding any research in China, particularly any virology of Wuhan. And I'm wondering what your thoughts are about that.
Yeah, that I think is really going to be a big mistake, because if you look historically at the collaborations that have gone on over decades with China, they've been important. But also, if you look at the diseases that have emerged of importance, SARS, CoV-1, COVID, pandemic flu, bird flu that threatens to become pandemic, for us to exclude a collaboration with the Chinese, we're going to have these diseases are not going to stop emerging because we don't do research with China anymore. It will only be more difficult to recognize them if we break off all of the collaborations with our Chinese colleagues.
Do you think you have enough support in Congress to agree with you?
I don't know, to be honest with you. It's a strange situation now in Congress. I don't know if I have that. I don't know if people are going to, because right now everything is anti-Chinese. I mean, it's radioactive, you know, practically to even talk about a Chinese collaborator, which is really unfortunate, because that's going to wind up to be to our detriment.
So Larry, I think we're going to give you the last word.
All right, well, I just wanted to say that, you know, I think what's been wonderful is to sort of see this amazing both breadth of knowledge, of scientific knowledge, and the ability to translate knowledge into policy, the leadership that Tony has had over the years. And I hope this fireside chat really just sort of shows what an extraordinary human being my great friend is. And it's really, I think, been a pleasure, and we thank you to be here. And my only issue is, or not issue, I'm going to only say one thing, is just throw the ball up high.
Thank you. Thank you. Thank you.
So, on behalf of the Hutch community, I want to thank you, Dr. Fauci, for visiting for being the second honorary recipient of the Hutch Award along with President Carter. And to say that there is faith in the future, I sat in front of a Democrat and a Republican state representative, okay? And I can promise you they did not argue at all during the entire talk, okay? So there is...
It's a good start.
That's a good start, and there is faith in our future. Thank you all for coming, and congratulations, Dr. Fauci.
Thank you. 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 All right. Let's go throw a ball outside.
Yeah, let's throw the ball.